Alright, so this video is meant to help review how to identify what type of bonding a molecule will have, whether it's ionic, covalent, or metallic, but then also to explain why metals tend to give up electrons and why nonmetals tend to accept them. And so in that explanation, we have two periodic trends that we're going to talk about. The first one is atomic radius. So atomic radius is simply the distance from the nucleus to the outermost electron, okay, the radius of an atom. And as we move across the periodic table, your atomic radius is going to decrease. And the reason why it decreases is because as you move from left to right across the periodic table, your number of protons increases. And since protons are positively charged, they're going to attract electrons more, causing the size of the atom to decrease. As you move from top to bottom on the periodic table, your atomic radius, which I'm just going to shorten with AR, your atomic radius is going to increase. And the reason why your atomic radius increases, as you move down the periodic table, your number of principal energy levels that your electrons occupy, remember for the first row it's 1, then 2, 3, 4. As you increase principal energy levels, the size of your atom is going to increase because the electrons are getting further and further away from the nucleus. The other trend that we need to talk about is electron affinity. And electron affinity is exactly what it sounds like. Electron affinity is an atom's attraction for electrons. So just like when we're talking about magnets that are close to each other, we put two magnets close to each other. One with a positive end, one with a negative end. The closer you get those magnets to each other, the greater the attraction is going to be. And the further apart they are, the lower the attraction is. So just like that, when we decrease the size of an atom by moving from left to right by increasing protons, the electron affinity, because the electrons are getting closer and closer to the nucleus, the electron affinity is actually going to increase. So atomic radius and electron affinity are inversely related. The lower your atomic radius, the higher your electron affinity. Therefore, since your atomic radius is increasing as you move down the periodic table, that means your electron affinity is actually going to decrease as you move down the periodic table because you're increasing the size of the atom. All right, so let's look at a couple of examples. Which has a larger atomic radius? Phosphorus or chlorine? Well, if you look, phosphorus is to the left of chlorine on the periodic table. So phosphorus is going to be larger. Why is it larger? Well, it's larger because it has fewer protons. Okay. The second one, which has a larger electron affinity, calcium or strontium? Well, if you look, calcium is going to be smaller than strontium because it's higher on the periodic table. It has fewer principal energy levels. And so calcium, since it is smaller, it will have a larger electron affinity. All right, so now let's practice our bond types. Keep in mind, there are three different types of bonds that we talked about. The first is ionic. In order to have an ionic bond, you need a metal and a nonmetal. And the reason why metals, because they're to the left-hand side of the periodic table, they're to the left of this staircase right here, they're going to have a low electron affinity because they're further to the left, while nonmetals have a higher electron affinity. So what's going to happen in an ionic bond is the metal, because it doesn't have a strong attraction for its electrons, is going to give the electron to the nonmetal, creating a positively charged metal because it's giving up electrons, and a negatively charged nonmetal because it's accepting electrons. That attraction between a positive and a negative charge, that is an ionic bond. So that's why you have ionic bonds being between metals and nonmetals. A covalent bond occurs between two nonmetals. And the reason why, if you have two nonmetals, they have very similar electron affinities. And so if they have similar electron affinities, one nonmetal is not going to give up an electron to a different nonmetal. Instead, in order for them to achieve the octet, which is the goal, right? That's when the atom is most stable. They're going to have to share electrons. So while ionic, a metal gives up an electron to a nonmetal for them to both achieve an octet. In covalent bonding, the nonmetals share electrons because neither of them is willing to give up electrons in order to achieve that octet. And then finally, we have metallic. And metallic is just going to be between two metals. And the interesting thing about metallic bonding is that since metals, both of the metals, or all three of metals, however many metals you have, since they have a low electron affinity, they don't hold on to their electrons. And instead what happens is they have a sea of mobile electrons. They literally just let their electrons loose and they flow throughout all the different atoms. And that's what's responsible for making metals good conductors of electricity. Okay, so let's work on identifying these 5 compounds. So CO3 2-, this is carbonate. The first element is carbon, okay, and it is a nonmetal. Well, why is it a nonmetal? Because it is to the right, let me show you really quickly, it is to the right of my staircase. Oxygen. Oxygen is also a nonmetal because it's to the right of the staircase. So since you have 2 nonmetals, it's going to be a covalent bond. Calcium and oxygen. Well, calcium is to the left of the staircase, so it is going to be a metal, while oxygen is to the right, making it a nonmetal. So if you have a metal and a nonmetal, you're going to have an ionic bond. Okay? Aluminum and lithium, an alloy. So that is a mixture. Aluminum is a metal because it is to the left of the staircase. Lithium is also a metal. So in this case, this is going to be metallic bonding. It's going to have a sea of free electrons. Lithium chloride. Well, lithium is a metal because it is to the left of the staircase. Chlorine is a nonmetal. So if you have a metal and a nonmetal, that is going to be ionic. And then finally, if you have H2, what that means is I have just 2 hydrogen atoms. So hydrogen, remember, is the weird one exception where when you're to the left of the staircase, it is actually a nonmetal. So this is going to be a nonmetal. The other hydrogen is also going to be a nonmetal. So since it's 2 nonmetals, this is going to be covalent bonding. All right?